So when setting up an experiment, we're going to have an independent variable, a dependent variable, a control, and multiple constants. But one more thing. We want to make sure that we have multiple trials. So essentially, we're going to have multiple sets of data or run the experiment multiple times. Each time we run this, we'll have more and more accurate data. As the more data that we have to average, the more accurate our results. We want to make sure that the experiment that we ran was not just a fluke. Moving on with our steps of the scientific method. Of course, when we run our experiment, we're going to collect some data. So the data would be the results that we get from our experiment. Now this can be in a couple of forms. We can have quantitative data, which is numbers, like we saw in our brine shrimp lab. We counted the number of brine shrimp that survived. Or qualitative, which is descriptive. Qualitative data can be just as useful as quantitative data. Don't be misled if it's not numbers. Once we collect our data, we're going to make sure that we organize it. So we can organize our data in charts or tables or graphs, much like we're doing with our brine shrimp lab with a chart and a graph. Once we analyze our data, we can form our conclusion. This is basically the answer to our hypothesis. So we loop back to the hypothesis to see, did we prove or disprove it? And more importantly, what have we learned? So we're going to use the data that we've obtained from our experiment to form our conclusion. The final step would be, of course, to retest. So we do want to make sure that our experiment was accurate, and therefore we'll retest that to verify those results. The experiment must be repeated and therefore retested to prove our results were accurate. Finally, there's a couple of important terms associated with experiments and running experiments. We saw hypothesis already, a testable explanation for our scientific experiment. We made a hypothesis before running our experiment. Theory and law, these come from running multiple experiments and making observations. First, a theory. Now, both theory and law are very strong concepts. A theory is an explanation based on scientific laws, facts, data, information that we know about the world around us. No evidence that we have has been able to disprove a theory. So a theory that you might be familiar with would be the Big Bang Theory. We can't recreate that. We can't show the Big Bang again. But all the information that we have describes how the Big Bang happened, and therefore we have a Big Bang Theory. Nothing has been able to disprove that theory. A law, on the other hand, is a proven scientific fact that describes how the world works. So basically a phenomenon that happens in our world. We can use multiple experiments and test multiple hypotheses to show and prove and demonstrate a law. Again, no exceptions have been found. So a law is something that we can demonstrate, the law of gravity. You can drop your pencil again and again and again. It will continue to hit the floor. The law of motion. So notice that a law is something we can easily demonstrate. A theory might be a little harder to demonstrate, but all scientific information proves that theory. So our scientific method is used to establish laws and theories as we look at the world around us.